Welcome back everyone. Now we are going to learn about what is the use of the memory address map. Well, as I told you that mapping system in the cache memory, we are going to discuss it in a little more detail here. And what I intended to tell you here is that memory address map is very important for any design engineer, or betterly say, if in for our subject, digital designing. So in the digital logic things, we need, or just the designers of the memory or the programmers, whichever way you like to call them. Well, any kind of these experts want to use or must have to use the efficient way of efficient of memory. They have to get efficient of the memory. They should know, and they try to put the things in the RAM and ROM in the least space with the most efficient way possible. So that's the whole story of the memory address map. And as usual, it is a map. Map means something that shows you the direction to go from one place to another. Like you have to reach this place, so there can be so many paths, so you have to find the shortest and the most efficient one to reach here, the tick mark that I made. Okay, so this is our destination place, and we need to decide that which way is more efficient and what are the requirement and the configurations. You surely have seen that 512 MB RAM is required for so many of the operation, and these days 1 GB, 10 GB even required if you are playing some kind of a PlayStation game and all that kind of things. So we require definite amount of the RAM and ROM to perform certain actions that is required by the software, by the program, and that program is going to decide at how much data at this speed it's gonna take. Otherwise, if you are playing a very heavy game, or if you are watching a 3D kind of a movie in a very small device which is not having very much space, either it will hang or it will not run itself. So we require so many lines, address buses, and all that things. And here we have memory address map that is made by the designer so that we can make the things in a better and more efficient way, and it don't get clumsy, it don't get trafficated, it don't get missed out and all that kind of things. We know exactly where to go and what to find, and that is the use of the memory address map. Okay, that's it for the memory address map. And now I would like to take you to the associative memory. I already made a rough chart of that also, that we can understand it quite clearly. So what is associative memory? First of all, in normal routine, when a particular data is searched in the block of memories, the memories are read one by one from starting to last. But surely it's not the most efficient way of doing so, because if your data is at the absolute last, you have to go through a very, very long way. Let's say that you have 1 million things that you have stored for something. Maybe 1 million is so much anyway, but if you have stored it and you are going one after another and your data relies here, so you have to travel all the way to 1 million, and that's huge, and that is not worthwhile either. That's why we don't study that. Thus, if the data element is stored in last memory of 2056 multiply 8 memory chip, well, you remember 2056 multiply 8, right? If not, don't care, it's just a configuration about the memory, nothing else. It's just a memory chip. So 2055 comparisons are done first, then you will able to reach 2056. Well, that's a huge waste of the time when we go. That's why the cache memory and all the techniques are designed to make the things more better. A memory unit accessed by the content is called associative memory or content addressable memory. I am repeating my words one again. A memory unit accessed by the content is called associative memory. So the content of the book, like this course is having sections. So you can just go to a section first, whichever section you want to repeat or whichever section you are studying right now, and then you can search that which class you have to find. Otherwise, there are more than hundreds of videos. So you have to look for every one of them to just know that what you want to learn. Like in this one that I made, you can just simply go in the first section to learn about the semiconductor, in second section to learn about the Boolean algebra, in the third one, then fourth one, then fifth one. You know exact description that what you want is where it's lying. So that's kind of the thing that I wanted you to tell. So first of all, it was a mapping. Mapping are done by the engineer before it's even been made, so that we can actually understand that where to go and how to design the things. The electronics people know that how to design the things, how to make the things happen. And associative memory is a logical part of that. Like as you can see here, let me show you by owning my laser. Yeah, here it is. Argument register goes to the key register. So it's about the register. Register stores the record, right? So it is recording everything, and then it comes to the associative memory, array and logic, m words and bit per word, then gives its output. It is also in the memory part, mass register, you can say. Register, wherever it's register, it's surely stored, so there is memory everywhere, so it goes unsaid completely. So whenever we get the input, we read or write, that depends upon us, and we get the output. So as you can see, there is a organized way. It is not messing up, that the CPU is not messing up. It knows that it has to go through argument register, then key register. Like I said, in the books you can see, just let's take a deeper example for it. Like I made a map when I was making the course, that which section I have to make and on which classes I have to make, and in each class on which time I have to address a particular topic. So if you want to learn the associative memory, what you have to do, you have to come to the advanced computer architecture section, then you will come to the associative memory section, and then you will actually find the associative memory. Actually, a step before is memory address map. So memory address map, this is the section, this is the key register, like you know, memory address map you have to come in, and then there is the associative memory that started after 4 minutes of this video. So this is a way that you know how to reach the associative memory. If somehow I tell you that here it lies, or you know already that here it lies, you go through this way, you follow this particular path, and that's the way it actually happens. So this is all about the associative memory. I hope you have learned something excitingly new. This was quite logical thing, a very simple one. Just a combination of the register makes our thing very simpler. Like whenever you have to search anything in the book, you just go to the index or the content, and then you just search the chapter and you look for the page number. You just go to that page number, and whichever topic you want, you reach to the closest or sometimes to the exact topic. That's what the associative memory means. I hope this becomes crystal clear to you. And now in the next one, we are going to learn about the mappings in the detailed way and which kind of the things are there. But before that topic, I will tell you something more exciting. So stick with me, take care, God bless, and see you in the next one.